A little bit about me first. I've been an R user for around 6 years. I first learned at Rice University, where I went for undergraduate. I'm currently a data scientist at DataCamp. I started just 2 weeks ago. For those of you who aren't familiar with them, they're a data science online education company, and they're sponsoring this conference, so you can go learn more about them at the booth. And a couple of things I enjoy talking about if you find me at lunch or in the coffee breaks. A/B testing. The talk I gave at Jared's meetup was all about online experimentation. I did a lot of it at Etsy, where I was before, and currently helping DataCamp build out their platform. Building and finding data science community. This is really why I enjoy being at conferences like this, because all the talks are recorded, which is great for those who can't make it. So you could see these talks, but really it's the energy in the room, it's the connections that you make when you see people in the coffee and the lunch that makes it so much fun to be here. And finally, of course, R. All right, I have 3 goals for my talk today. The first is to keep you hip to the lingo. So I'm talking about the Tidyverse, but what is this Tidyverse? How did it come about, and who are the people behind it? And the second is to stop you from doing this. We've all had those moments where we know exactly what we want our data set to look like, how we want to reshape it or the model, and it just won't work. Hoping to help solve that by teaching you some useful functions you can start doing right away in your workflow. And finally, point you to some resources. I'm hoping at the end of this talk you'll be excited to learn even more about the Tidyverse after understanding better its breadth and how the functions can work with your data analysis process. And I want to help you start that journey, so that will be the closing part of this talk. All right, the Tidyverse. Tidyverse is a set of R packages that are designed to work really well together and to bring you through the data analysis process. This is what the Tidyverse universe looks like. Most of us are probably familiar with these steps. First, you have to even get your data into R. Then you work on changing it. Maybe you have to munch some dates. Probably you'll try out some visualizations, plotting your data, hopefully with ggplot2. And then the final step is usually to communicate it to other people. You might do that through a Shiny interactive dashboard or an R Markdown document that you make to a Google Doc that you share with stakeholders. And what we see throughout this process is written below the big steps, import, transform, are just some of the Tidyverse packages that can help you through this. Now, most of you here are probably familiar with this man. He is going to be speaking. Hadley Wickham, for those of you who don't know, he's the author behind such packages as dplyr and ggplot2. And if you've been around in R for a few years, you might have heard the term the Hadleyverse, talking about these packages. So a question could be, is the Tidyverse just the Hadleyverse? Is it just Hadley Wickham? The answer is absolutely not. Yeah, this is the first time I think I've had Hadley in the audience for this. But what I wanted to show with this is that Hadley's done a great job starting this, but here are some of the packages in the Tidyverse. And these are the people behind them. In some cases, they're the creators of the package. In other cases, they're the current maintainers or active developers without whom the package wouldn't look like how it is today. And that's what I really wanted to emphasize, is it's grown, much beyond one person, and really now there are lots of contributors, lots of packages in the Tidyverse, and it makes it a really exciting place to be. The main part of my talk is going to be this demonstration. I'm going to walk through an exploratory data analysis of Kaggle's Data Science and Machine Learning Survey. This was something they did in 2017. They surveyed about 16,000 people, ranging from those just starting in data science to people already in the field, asking questions on their demographic information. What are their favorite learning platforms, or what machine learning methods are they excited about next year? And some steps of a data analysis workflow I'll walk through, going from everything to viewing our data set initially, inspecting some different columns, making plots, and maybe everyone's favorite steps, doing something really cool and new. All right, so first step, you just type the name of your data set after you've imported it into your console. And who's ever had this happen, where it just takes over the whole thing and you're like, oh no, what have I done? What mistakes have I made? And what's happened is you have so many columns and it's printing all of them out, and this is really not a useful way to view your data set because it's just completely taken over. And the solution to this is to use the function asTibble from the Tibble package. Tibbles are modern data frames, and they changed a few behaviors about data frames, but one of the great ones is that they will only print the first 10 rows and the columns that fit on the screen. So what we can see here is those rest of those columns that were, the rows of those were all printing out. Now we just see the column name along with its type. So this is, you never have to worry about that never-ending console screen again, I guess unless you have maybe 10,000 columns. Don't do that. Next up, examine your NAs. As we heard in earlier talk, missing values can be really important. So how do you take a look and see what those missing values might be? One way you can do it is first you do this combination of sum and is.na. Is.na will change the variable country to true or false, depending on whether it's missing. Then we sum it, and because true evaluates to 1 and false to 0, that gets us the number of NAs. And using dplyr summarize, we can get this so that now we have just a one-row data set that's the number of NAs, and it's 0. But how can we do this for every column? I don't want to be running through each column name doing this. Here's where purrr can come in. So purrr, to me, initially was a very intimidating package. It's all about functional programming. It has a lot of stuff. But I just want to share it with those who aren't familiar how you can start using it. And what here I'm going to do is map this function, sum is NA, over every column. The map underscore df says I want a data frame back. So you have map underscore chr. I want a character back. And that's how you tell, and we can see I do get indeed back a data frame of 1 row and 228 columns. And what's in the row here is the number of NAs in that column. And the way I've said this is the dot that's in here says, this is where the column should go. This is what I want, where I want you to do the function. And that little tilde just stands for an anonymous function. And this is a really nice way to do something over every column. But what's the problem here? Let's take a look at gender select. It said that there were 0 NAs. Well, what do we see here as humans? There are 95 people where it's an empty string. And we recognize that as NA, but R doesn't. And our missing values aren't actually NA. To solve this, we can use dplyr's NAIf. And this says if its argument is what we want to change to NA. In this case, we want to change an empty string to NA. And now if we once again look at our gender select variable, we see, just as we would hope, the 95 entries are NA. Next up, let's examine some of our numeric columns. But how can we do this quickly? We're going to use a combination of dplyr selectif and skimr/skim. Selectif, you might be familiar with dplyr select. Selectif says, I only want to select the columns if a condition is met, in this case that they're numeric. And then skimr/skim gives us a really quick overview. This is a lot of the summary information you'd probably want, starting with how many are the missing, what's the mean, standard deviation, what are the percentiles, and finally, probably my favorite feature, the histogram, where we can immediately start seeing some things like, oh, we might have a data quality issue because age, the minimum age is 0 and the maximum is 100. Probably we didn't have 0-year-olds taking our survey. Next, let's go back and examine a single column. This is the column work method select. And I'm just doing a count and I'm seeing, OK, which, let's summarize the data a bit and see what are the more popular work method select. What's an issue we have here? We can see that this must have been a multiple selection question. So each row is, represents like a person's answer. And the problem we have here is some of the answers have 2 work methods selected. Like we see the 3rd row, data visualization, logistic regression. So if we want to understand what's the most popular work method, this is not a really good format for our data to be in. And to help this, we're going to use the stringer function string_split. Stringer is all about working with strings. And in this case, we'll say, take that work method select column, split it based on the comma. With that, make a new column, work_method, and let's take a look at that. And now what we have is a column of lists. So that first row is a character list of 5 entries. And that used to be 5 things split by 4 commas, but now we've got a list. But that's still not the format we wanted it to be in. So how can we spread it out so now once again, each row will only have a single entry? And with that, we do Tidyverse unnest. So we take this data set, which has a list in each row, and we spread it out. And we end up with over 68,000 rows, because now it's much longer. And with that, we can start trying to visualize. So let's make a plot. Let's do a plot of, as we wanted to ask, what are the most common work methods? And we have a critical issue with this plot, which is it's a mess. This is not helpful, right? What the heck are these axes? What are the labels? So we're going to do 2 things to solve this. The first is a chord flip, and this is really nice. The other option would be you can make your x-axis labels vertical instead of horizontal, but I personally like the chord flip a lot. And now we can read it, and that's okay. That's more helpful, but we still have a problem. They're not ordered. So let's order them, and with that we can use forcats, which is one of my favorite packages. It's around working with factors, and here we're saying, okay, let's reorder the work method column by n, by the number of people. And now we can see that, oh great, this is much easier to read. We start data visualization, logistic regression are the most popular, versus like GANs are all the way at the bottom, not very popular. Our final step in a data analysis process, right, as we heard, it's maybe just 5 or 10% of time, but it's doing something cool and new. And what's the issue we have here? We have no idea what we're doing. So who's run into you're so excited about a new method, and you're like, I don't even know where to start, or I just ran into a bug, and why isn't my code working? There's a lot of options you have here, such as reading the manual. But another option is that you can ask a question. So if you want to ask a good question, like say on Stack Overflow, RStudio Community, or Twitter, a good way to do is to make a minimal reproducible example, which is all about helping others help you. And we're going to do this with 2 packages, Tibble and Refworks. And first, just to clarify, a minimal reproducible example is, let's say you asked a question that says, why isn't factor reorder working? It would be very difficult for anyone to answer that for you, because they wouldn't see your code, they wouldn't know what data set you're working at. But what if your code is 1,000 lines and your data set is proprietary? Well, you can't really share that either. So a minimal reproducible example is about reducing your code to where it's to the shortest possible amount of code and data that still illustrates the problem you're having. And this is an optional part, but one way, if you need to make a kind of fake data set to do this, you can use Tribble to make a toy data set. And Tribble is how I always dreamed of making data sets in R, which is just on the first row, you list your column names with a little tilde before it, and the next row is just all the entries. And here I'm just saving that as an original data frame. Next step, we can use the package Refworks from Jenny Bryan to find any problems. What do I mean by that? Let's say we have our code. So on the left here, we've said, OK, this is the code that's having a problem. Let me try Refworks. I copy it, I run Refworks. But oh no, I'm having errors. So if someone was running this in a clean R session, they would have errors. And not the errors I want them to have, but the errors because I haven't loaded the packages. So in this case, if we look at what errors are going to come out, it's, oh, I can't find the function vismiss. I can't find the function ggplot. We go back to our code and realize we haven't done the library calls. So Refworks will help you find those issues before you post and someone goes back and says, hey, I can't run your code. And then we can use Refworks to post your question or issue. And that's really nice. Say, in this case, we're seeing an example where you posted it on GitHub. Like maybe you want to file a bug report with a package. And the nice thing is it formats your code and includes any plots and makes it really easy just to go and submit your issue just by copying it. All right, so this is just an overview of what we went through today, about 11 functions. Like I said, there are so many more, not just packages, but functions within the packages. And that's why I wanted to go over, for example, dplyr, which is a very popular package, but many people don't realize the depth of the functions that it has. At the resource at the end, I'm going to point you to some places where you can find out things like that. First resource is Hadley Wickham's and Garrett Grolemann's R for Data Science book, which will probably be given away at this conference. It's available for free online, and it's a really good resource. It's appropriate for both beginners, so if you're just starting out in R, but also even for more advanced R users who are looking either to maybe wholesale switch into the Tidyverse or have been using the Tidyverse but aren't familiar with certain parts, such as maybe working with dates. And then they can go to this book and just jump to the chapter or section on that. Next up is the RStats Twitter hashtag. So I'm a big Twitter user, and one of the reasons I like it is it's a very friendly community. In this case, I was saying, what happened was I had a report that I was writing at Etsy, and I had about 12 plots in it. But I was going to share this with a lot of people, so I wanted to make those plots use the Etsy color scheme. And I knew about theme_set, which is a way at the top of your script you can set the background for your plot, and that will change all the plots later. But that didn't work for colors, and I wanted to know how can I globally change the colors on my plot without having to go and every single plot add the color scale that I wanted. And RStats Twitter came to the rescue. So Ilde Sessler here said, did you know about this package, ggtheme-r? Here's the functions in it, and here's a blog post I wrote about it. And this was a really nice way to get an answer to a question that the Googling hadn't done for me. Next up, our studio has lots of cheat sheets. You can find them at their table in the back. This is Purr. I like it, again, as both a reference, but Purr is often thought of mainly for its map function. But this is a two-sided cheat sheet, and there's so many more functions that you have here. So whether it's you want to dive into a package or you want a one-stop shop for working with strings, you can go to our studio cheat sheets and find those. Now, of course, I'd be remiss if I didn't mention my company, DataCamp. I actually had this in my presentation even before I worked with them, and that's part of why I was so excited to join. As I mentioned, it's a data science online education company, and it's a little bit different. We have a couple of things. We have projects and problem sets, but one of our main things is courses, and these courses are 4 hours, so they're a lot shorter than, say, a Coursera course, which might run over a few months. We have people like Charlotte Wickham, Hadley has a course. I'm working on a course right now on categorical variables. And the way these courses work is you watch videos and then you do these interactive exercises right in your browser. So it's a nice way if you're just starting to learn, like R, Python, or SQL, to not have to download anything and to get immediate feedback. All right. In conclusion, I wanted to say again that R has, we're great. We have, as Christine Zhang here is sharing, we have all these awesome stickers. Again, you can find some of them in the back. Cool package names. So maybe that's how we can help attract people initially, but really staying for the friendly community and happy workflow. And that's part of why I love so much being part of the R community. I work with Our Ladies Global Organization, advancing gender equality in the R community. And we've had such an outpouring of support from a lot of other people in terms of sponsorships. And I really think that just shows that R is really, the people helping lead R do not want to be elitist. They don't want to exclude others. R is meant for people who, in some cases, are never going to be professional developers. And that's kind of what the Tidyverse is about, is even if you don't want to go deep into, let's say, like advanced programming, which you definitely can in R, the Tidyverse gets you doing powerful things very quickly. And with that, I want to say you can find my slides very soon on this link, tiny.cc New York R Talk. I blog about some of these topics, like finding data science community, making R faster on my blog, Hooked on Data. You can find me on Twitter, Robinson_ES. And with that, thank you all so much.